Okay, so I have the honor to give a talk with Joe and Martin about how we build our edge solutions, like we've heard a lot this morning, and we're going to see what we have learned from our customers. And what are we going to do today? We're going to look again into Cloud Native Edge, so how that's going to look, then SUSE Edge Suite, well, what's the components, what do we use, and then we're going to dive into the environments, the requirements, everything you need to know to build it, and then you'll see how we've designed it for a couple of our customers. And then in the end, we'll tell you a checklist that you will need to prepare, that you will have to have ready for your day 2 operations. And with that, I'll hand over to Joe. Oh, we didn't do an introduction round.
Yeah, I just do it now. Yeah, my name is Joe, or Joachim Werner. I've been with SUSE since 2004 in various capacities, and currently I'm the principal product manager for everything Edge that's not telco. Let's put it that way. Yeah, so I'll start with a little intro. Whatever Edge means to you, originally the plan was we have a book that is really nicely written as a collaborative effort by the team, but it's still in US Customs because it's coming from China. So yeah, maybe after the show you'll be able. It's available as a PDF on the website. So I'm using my own simple definition. Basically, what all the Edge solutions that we have been implementing have in common is we have lots of stuff. So we are not talking about snowflakes, individual servers or one implementation, but usually hundreds or thousands of locations that have to be deployed and maintained in lots of places. Yeah, not just in one data center where we would have like the chance to send an expert and maybe have staff on site. And you never have enough resources. And of course, stuff you saw in the morning in the keynotes, like it has to be secured, you want secure life cycles and so on. At SUSE, we think one of the best solutions for implementing that is what we call the Cloud Native Edge. And what I mean by that, well, and why you should care is, let's just very quickly discuss what Cloud Native means. I guess most of you have an idea, but just to set the stage a bit, the idea of Cloud Native is that, to oversimplify, you try to have the team that is implementing a certain feature own the whole stack. So let's say you have a team that builds a certain integration between your backend ERP system and your web frontend. They own the whole thing. They build microservices. They put them into Linux containers that they can test locally, that they can then hand over to QA that are then deployed in production. Most of the time, yeah, you can basically automate the whole thing, even like in a continuous integration. Of course, once you have modularized your application stacks, you need to orchestrate it, because a microservice on its own is not doing much. That's where orchestrators come into play, and I guess we all agree that Kubernetes has won the war for the orchestrator. Originally a Google project, and for many years now basically the default for orchestration. And finally, because you don't want to set this up once, you want to be able to replicate it in different locations, have different instances and so on. You need a way to describe that infrastructure. And the concept that has been adopted there is GitOps, which basically means we take all the lessons learned from software development, so collaboratively working on version code bases, having social contracts between developers where someone will maybe check your pull request and approve it. You can have all those processes. And just like in software development, you'd have a make file that describes, okay, this is your source code, your C code, and the make file tells the build system, okay, how to build it and create a binary from it. In this case, you have that same kind of make file, but it will build out your actual infrastructure. So it goes out, let's say, into a cloud service provider's infrastructure, provisions virtual machines, brings them back, sets up Kubernetes cluster, and so on. Yeah, and of course, if you look behind the scenes, it's all open source. Yeah. So the world runs on open source these days. If you go to any of the large hosters, yeah, that's cloud native. And when we bring cloud native to the edge, basically what we want to do is we want to make sure that the infrastructure you have in, let's say, a retail store or on the factory floor has all those capabilities. And if you want to deploy applications, it's as easy as bringing a new web feature to your customer-facing web portal. Yeah, the stack that we are using for that consists, of course, of a server side and a client side or downstream cluster side. The server side is basically best of breed of all the management tools that we have at SUSE. The Rancher side, it's all, I mean, you saw it in the morning already. So we have SUSE Linux Micro as the underlying OS. We have Kubernetes. So Rancher itself is a Kubernetes workload, but it's also managing those downstream Kubernetes clusters. And what we've added in the Edge suite is what we call the lifecycle controller. This is another abstraction that makes it super easy to update the whole stack. So basically, the update controller would, the lifecycle controller would just take the version of the SUSE Edge stack you want to have, make sure the OS is updated, the Rancher is updated, and all the containers in just one simple step. We have the GitOps integration. At SUSE we are using Fleet, but of course you can, in some cases we have customers using Argo CD, so you can use other CI/CD frameworks just as well. The metal cube part up there is not usually something we see in our industrial use cases. That's if systems have management board controllers, BMCs like ILO or iDRAC, you can use CAPI, the cluster API in Kubernetes, to just talk to those boxes just as if they were a public cloud. So just like you can go to Amazon and say, give me 5 virtual machines back through their API, you can go to Metal Cube behind the scenes goes out and ask the BMC, okay, can I attach a Linux installation media, brings up a server, and you get it back. Yeah, and then on the other hand, we have SUSE Manager, or now SUSE Multi-Linux Manager, MLM, that we also have in the stack, and I guess you'll cover some of those scenarios. Both of them are well integrated into our build tooling. The downstream cluster can be a cluster, but it can also be just a single node with K3S, our Kubernetes optimized for the edge. Yeah, you can run this on a single node, 3-node cluster, whatever makes sense in your ecosystem. As part of the so-called SUSE Edge suite, SUSE Security is included, SUSE Storage, so the Longhorn project is included, as is both virtual machine management with KubeVirt. If you want to know more about that, look at some of the SUSE virtualization talks that we have at SUSECon, and container-based workloads. Yeah, then of course we have tools for building out that stack. The Edge image builder allows you to either just build an image that is intelligent enough to connect to the Rancher server, and then you do the rest of the deployment from Rancher, but you can also use it in a more or less air-gapped environment. And on the USB thumb drive, you already have all the stuff you need to install your Kubernetes, so the K3S or RK2 binaries. You have all the Helm charts. You have a local registry that's on the ISO that has all the containers, and we automatically take the Helm charts and make sure that the actual containers are referencing the local repository, not a public container OCI registry. Yeah, and then basically that's of course the stacks. Yeah, I'm repeating the question. Yeah, so when you build a local installation media with the Edge Image Builder, What it will do is download all the resources from the Helm chart, then rewrite the URLs in the Helm chart. There may be some cases, so I always, of course, QA it, but it has been working really nicely. And then when you use it offline, basically, yeah, all the resources, all the containers come from the local registry. It's the Hauler project that the Rancher government guys have invented. Yeah, exactly. So, and with that, I'm at the end of the intro. I'm handing over to Martin.
In this room, yeah, it's working. So, in this room, we have a lot of fun this week with the microphone, so sorry for that. Basically, I didn't introduce myself now, so I'm just speaking a bit about myself. So I'm working for SUSE since a bit more than 20 years now. Have been working on all the products we have in our portfolio, which basically brings back everything we have in this solution in the meantime, because it's basically across the board in our portfolio. Edge is basically a big combination of what we have in our portfolio since ages. So I always refer Edge as some box with Lego pieces, and we have to take these pieces together to fulfill exactly what you need in your environment. So the whole solution is super flexible, can adopt it to be working in different scenarios, different use cases. And Dominic and myself have been working from a consulting side of things with a few manufacturers in different projects. And we have learned out of that, and that's what we want to share here. So as a disclaimer, basically we are not going through all the technical details. It's also not touching on all the components we have in Edge. It's basically picking out the most important things that we have been reusing in different environments. But as always, for each and every customer, we had to adjust it a bit. And basically what we are doing from a consulting best practice is normally we go in an engagement, and the first thing is we feel the pulse of the environment, which means we look at the environment, we do sort of an inventory, check what's there. After we understand where the customer is, what is in the environment, we look at the requirements. So what do we want to achieve? What are the challenges, etc.? I go into that in a bit, into details in a few minutes. And then when we know the current environment, when we know the requirements, we go through a design and architecture exercise with the customer to figure out what pieces of the Lego set we are taking for which components, which functionality, what features we use. After that, we do the implementation, we do a test, and then hopefully we are successful and roll it out, or we iterate and change until we are happy. And we do that these days also in an agile way, because all the cloud native way is a bit of a trial and error thing. So we do things, learn out of them, change, adopt, until we have a solution we are happy, and then we are rolling it out, replicating, scaling it, etc. So as the first thing I said, we look at the environment and put our hands on and feel the pulse. So whenever we look in the environment, so when you look at your environment or your customer's environments, these are the most important things you need to understand before you can implement any sort of edge solution. So we need to look at the infrastructure. Is it a customer with 1 location, with 100 locations, with 1,000 locations? Is it locally, globally, etc.? Are we using only on-premise technology, or are we using public cloud? So we have customers in both scenarios. So we have been using Edge for highly regulated, isolated scenarios, and for customers that have components in the public cloud as well. So we really can adapt to what the customer needs and where they are. Then the next thing is, this is a really key thing, we need to understand the connectivity situation for the edge devices. So we have a huge range of connectivity situations. We have situations where we are completely disconnected, satellites that don't even have a connection, or ships or something like that that are completely disconnected, or that are partially connected, which means They are only connected when they're in the harbor. So we need to think about how to deal with these different scenarios, and that's why we need to understand what connectivity situation are we in, and what is the way of communication. Do we have proxies, firewalls, etc. in between to take care of them as well? Then we need to understand the networking. So what addressing ranges, how is the addressing handled? Do we use IPv6, IPv4? Do we have static addresses? Do we have DHCP? All of these things. How do we manage these IP addresses that are used? Basically, each and every device that you want to deploy needs some sort of identity and IP address. How do we manage that if we have thousands of devices in multiple different places? Then what bandwidth do we have? What latency situations do we have? Do we have load balancers here or there? Then we need to understand what hardware is used at the customer. So basic thing is, which architecture is the customer using, x86, ARM, or maybe something else. At the moment, we only support ARM and x86, but who knows? Sometimes certifications are required, so we need to see if the customer has some certifications we have to align to. And we need to understand what's the support scenario for the hardware they're using. What I mean by that is, if you buy hardware today, and if it's on the edge, there are situations where the hardware needs to be supported for 10 or 20 years. So one of our customers is planning to deploy something on hardware, for example, to monitoring tanks, and they want to use that solution for the next 10 to 20 years, which is really a support challenge on the hardware side of things as well on the software side of things. So these are basically the things we need to look into. And then whenever we deploy something in IT infrastructures, we have a set of dependencies to outside services. So especially time synchronization. Without time synchronization, nothing works these days. SSL certificates are a good example. So if you buy hardware that doesn't have an RTC battery backed, so real-time clock battery backed, you run into situations when you power it on, it doesn't trust your certificates because they are not yet valid. So things like that happen. So we really need to look into the time synchronization thing. We need to look into the name resolution thing. We depend on things like registries, Git repositories. There are a lot more things, but we really need to see what is there already and what do we have to add as part of our stack or what the customer needs to do. So once we understand where the customer is, the next thing is to understand what are requirements for this edge environment. First of all, basically that's a general cloud native thing. The first thing that you need to understand is what will be the workload that you have to host on these edge devices. Because that's the key for deciding how do we get it installed, configured, rolled out. So if the workload, for example, needs 10 terabyte of disk space, we don't have to think about K3S with a 100 megabyte binary. You know, that doesn't matter anymore because we need a huge thing for the workload. So we need to understand CPU, memory, disk space requirements, performance, connectivity, all of the things that are workload related. We need to understand the workload first because that's the thing we want to run in the end. That's the end user using or the machine that is running out there. And then we need to talk about availability. Is it okay to have downtime or not? Do we need single nodes? Do we need multi-nodes? How do we do the connectivity? Do we need bonding, multiple network connections? How many network connections do we need? Do we need to build big clusters, small clusters? A lot of variables are there. What scale do we need? Do we need to dynamic scale up and scale down? Do we have performance requirements? And basically then the next thing, I already mentioned the hardware they're using. Here again, we have to look into more details of the hardware because for the edge solution, based on the workload, we might need GPUs in these devices. We need to support them. We need to take care of how to manage, integrate them. We need to see what physical interfaces are in the box because especially in the machinery environments, you have CAN bus, you have different serial ports, you have a lot of different physical connectivities. And in this case, we need to understand that because that also comes back to the question, is that supported by SliMicro or do we need additional drivers? Where do we get them from? Is the hardware vendor delivering them? Is it supported? Whatever. And one of the other things is, do we have TPM modules in these devices? So for security reasons, for device identifying, we are relying on TPM in one or the other situation, or for disk encryption, we need TPM. But there are regulatory situations. I learned that from one customer, that if you have a TPM module in the box, you might not be allowed to export it to China. So these are just a few things that you need to understand from a requirements point of view. Kubernetes dependencies, I don't go into all the details here because that takes too much time. But we also need to understand what dependencies the application stack has or the workload stack has on the Kubernetes side of things. And then we need to check out what versioning and lifecycle dependencies we have. One of the big problems in the cloud native space these days is we are installing 100 different modules, 100 different packages from different sources, different Helm charts. And all of them have their own life cycle. So aligning all these life cycles is one of the key things you as a customer or partner needs to do, because if you have to update one part of this stack, it might break everything else in the stack if there are dependencies between them. So we need to look into all these life cycles, and that's where our application collection comes into play, where that makes a sense because we deliver new versions once they are available. But it's more important to check all the modules on your side to figure that out. Last but not least, security. We heard that pretty often. We need to understand what are the security requirements for this environment. Is there a physical protection already? Or do we need to have additional software protections? Do we have to fulfill some regularity requirements regarding security, regarding packaging, regarding delivery chain, NIS2, or whatever, you know, all these terms? Do we need full disk encryption? If we do that, how do we implement it? How do we make sure that when there is data on the disk and the TPM module gets broken, how can we access the data? So there are a lot of things you need to think about. What are the requirements that then result in a specific design and architecture and implementation? And you need to understand if there are some specific process and operations requirements from the customer side of things to adopt to that. Process definitions. Basically, whenever we look into rolling out 3,000 devices or 100,000 devices, basically we have a large-scale scenario. We need to think about how do I manage the identity of my devices and how is the process looking like when I get a new device or a device replacement. So in some scenarios, so in our customers, we have the situation that some guy in the remote location wants to have a new application on his shop floor. And then he starts an ordering process with a central location telling them, I want to have an IPC with this and that software, with this and that configuration. Then the device is ordered at a vendor, and the device is delivered directly to the target location. It's connected there, and you need to figure out how this process looks like, because that's exactly where you have to integrate your solution for managing what software is going to end up on that device, how is the device named, how is the IP address given, how is the software assigned. That's something you have to work out. So you have serial numbers, MAC addresses, a lot of identifiers, but the solution you're building needs to fit into that process. You have to build your operating system. You have to figure out how do you want to do that. Do you use SUSE Rancher that? Do you take the one from SUSE directly? How do you customize it? How do you reset the device if there is something broken? How do I do the application configuration? How do I do the assignment of these applications? Basically, if I have one application that monitors a specific machine in a remote location, somehow I have to configure that. So with Edge, we can put that in Git, we can use Fleet and assign it, but this process needs to be defined. How do you do that? Hardware lifecycle, you'll have to think about new devices. You have to think about broken devices. So for example, if you take the MAC address as an identifier, and then the network card breaks and you replace the network card, the device gets a different MAC address. How do you manage that? Or do you throw the device away, give it a new one? And how is the replacement process in the end? And how do you retire? So after 20 years, how to get rid of that thing? The same is true for the software lifecycle. What is the process of updating the operating system? How often do you want to do that? How do you do quality assurance? How often do you update Kubernetes, the applications, etc.? And with that, I'll hand over to Dominic, and he will guide you through design and architecture after you got current situation and requirements and processes. Wait, questions so far? Anybody awake? Okay, fine.
Okay, microphone test, yeah. So, I had one job in, my voice is not the best, but I hope you can understand me. So I had one job in the beginning, and that was to do the introduction. I guess I failed that one. So my name's Dominic. I work for the consulting team. I work together with Martin on a couple of our customers where we've based that on. So now coming to design and architecture. One of the things that Martin already said is we need to think about the processes. So a lot of this is actually not doing tech, but designing processes, because we have everything in place, right? So Joe told you we have all the technology. Now we need to fit the puzzle. So the first thing that we found is a thing called Configuration Management Database, or CMDB, as we call that. And we don't want to build that our own. But for the clients right now, because we don't get the integrations, we built a web server that serves it. What does it do? It does the identification of the devices. So a device registers up, a device is then assigned to a location, gets the configuration, knows what it needs to do. You want to ideally have that in some external SAP database, for example, or something centrally managed where you can build the whole process in. So that's one of the key things that we found that you need to think about. So next is we need to implement OS image creation, and this is something that we haven't seen or the others haven't talked about, frozen patch levels. Basically, you need to have reproducible builds. You need to know what you ship to production. So we introduced our SUSE Multi-Linux Manager there to do that in combination with the Edge Image Builder. So we do create the packages that we need with Kiwi. We then build everything, and then do the customization with the Edge Image Builder afterwards. That then does allow you to do the initial configuration of networking, where you say, I have a static IP address based on that MAC address, and then this is all puzzled together. Now, what we've done for Kubernetes is probably not a surprise. We used SUSE Rancher Prime and Elemental. So we have an integration into Suma, an integration into SUSE Multi-Linux Manager and into Elemental, so that we can do both workflows. So think about it that way. If Elemental fails or SUSE Multi-Linux Manager fails, you still have one way of doing things, right? Then for our customers that we have right now, they're using, the one is using Flux, so we're building a fleet integration with Flux so that they can still deliver it, and then planning on moving them over. But for us, GitOps will be fleet mainly, but we're open. So we do whatever the customer wants to do. And networking is really straightforward. We use our CNI for the Kubernetes pieces, so just regular. Right now, most of the times K3S, so there's not much configuration anyways. And then with the Edge Image Builder, we do a bit of magic for some of our customers. So writing a custom script that reads from the CMDB, NIC1 needs to be in this VLAN, NIC2 needs to be there, and so forth. But that is highly dependent and highly customizable, and you will have to adapt it for every customer. Storage, right now, most of our customers, we implement SUSE Storage, so Longhorn. And with that, you can do then distributed. But if you don't need it, depends on your applications, right? If your applications don't need distributed storage, for example, you have a database that does the replication, then you don't want to do replication on top of replication on top of replication on top of replication. So then maybe the local path is already enough for you. And then, of course, if there is NFS or S3 or whatever, we'll integrate with that as well. Oh, okay. Learning things, green on green with white doesn't look good on a beamer. So basically, this is a very stripped down version of what Joe showed you in the beginning. So basically, we have the Rancher Manager up here with 3-node HA installation. That is mainly for the elemental pieces, right? So elemental connects up. What does it? It registers in the first place, then does the TPM authentication, does like I'm IPC whatsoever, and then we can select, okay, that IPC, serial number, blah, 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 MAC address, blah, 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 goes into that and that and that cluster. And then we can build dynamically into different clusters, right? So we have those IPCs, we know they're at customer A, and then we can automatically put them into a cluster. And we do that with the elemental agent that then creates K3S automatically for us. And then as well, we have Suma with the salt minion here. And the salt minion basically allows us to do patching, to do like an emergency shell and stuff like that. And we had another arrow up here, which is our infamous CMDB, which just should tell you again, think about externally managing the workflows, right? So you need to know at customer A, we have device B, because if you have to have a replacement, you need to know where is what device in which cluster, and you don't want to do this manually. You have to design a process. So that's why in the beginning we thought this talk would be very, very technical, but then after working with the customers and figuring it all out, it turns out most of the time we're discussing process and not technical stuff, but process stuff. So last steps that we did in the design phase is basically we need to know where our image comes from. So we have the application collection that we integrated. We have the BCI that we integrated for them. So basically we're trying to tell or teach our clients how to use it, how to build secure images, and how to ship them. And then in this case, we have a very interesting detail here. So you see air-gapped registry. So we have one of those clients that is partially online. So partially online means we are on a shop floor, and the shop floor basically allows you to do maintenance in a certain time window. And they only allow you internet access during that time window. So what we need to do is to be sure that everything works in the time window, so we have a preloading stage of the images. So we've already spoken about Hauler. This is the tool that is on there, the embedded registry, basically. But we then also have a private registry. It's a new name. SUSE Private Registry was introduced this morning, Harbor, basically. What we have done there is basically allow or create a script that allows us to pre-pull it into that registry, and then as soon as we have the go from the customer, we can then say, okay, now let's do the application updates. There is one thing that is always a bit tricky to do with the customers and with our application stack actually is how do we deliver secrets down into the cluster. So what we've done is we've worked with Fleet and the external secrets operator. So external secrets operator pulls secrets from somewhere else and puts it down into the cluster. Why do we do that? Well, we don't want to store our passwords in Git, I guess. So that's why we need that. So we store them in, for example, AWS or in a HashiCorp Vault or anything externally where we can pre-fill it, or even in our CMDB, depending on what is supported by the operator. Backups. Well, all of your customers will tell you, no, we don't need a backup. It will fall over, it's stateless. No, don't worry, no backups. And then after a couple of months of an engagement, you will learn this one application, it's quite crucial, should maybe be backed up. But you said no backups? So think about backups from the beginning. They always tell you they don't need it, they will need it. So we do, we do support the CSI snapshots, writing it somewhere with Longhorn, for example, to S3 or NFS. We can integrate Valero. We can integrate custom, depending on what the customer actually has and what the customer actually wants to use. Good. Now, we've done all the feeling the environment, doing our design, and now we have to actually get our hands dirty and do the implementation. So, for all of the steps, we have to firstly plan what we're doing. Makes sense, right? So we need to know what we're doing, what we want to do, what we want to achieve. Then we need to define tests, need to basically define acceptance criteria, and then execute. Do it, document it, learn from it, and repeat it. Doesn't come as a surprise. It's an iterative process. I guess all of us have done it. What we've done so far with most of our clients is we start with something like a pilot or a proof of concept, or however you want to call it. So that is to show the tech can fulfill the requirements, we can get the approval from management, and then we can go further. So we have done that, iterated, and now we take it to a run with some friendly environment. I work with one of our telco customers. We like to call it friendly customers or friendly environments. It's not that bad if it breaks there. It's not great. It's also not that bad. So they won't sue you. So you can do a bit of testing. You have a good relationship with them. It's important because, it might break. Then from that, and why do we do that in the live environment? Runs on my machine, same thing here. We've run that in a lab, works perfectly. Then you bring that to the customer and realize, yeah, they have completely different network setup as we do. They don't provide this and that and that. And then you will learn from that. You will put that into your documentation. You will know, okay, we got to do that as well, and then iterate over it again. So after friendly customers, we'll build an MVP. Then we get the next nice grin from our management. And then at some point, we deploy it to a small set of environments, always like roll out step by step, and don't like push to production yet. We test, we learn, we adapt, and then at some point we can roll it out globally. But it's most important that between those steps, you're 100% confident that this will work. Good. Last slide, I swear. So, checklist, day 2 operations. Now we built the system. It's a year later. Ideally, it's 3 months later. And we figured we need to do updates. Or we need to, have a checklist of things to do on day 2. And I noted it there in the subline, which is we need to define and hand over to operations. Because, the two of us, we're from consulting. At some point, we're not going to be there anymore. So we'll have to, and especially, if you go back here, this is usually done by some sort of an engineering team, or maybe even research and development team. That team will not be there anymore. So we'll have to think about all of the day 2 operations, define them, have processes for them, hand them over, do test runs with your operations, and see that everything works. So, up to the top, we have failing hardware. Device replacements, new devices, that needs to be handed over. How do we do it? What do we do in our SAP or wherever we're storing it? What do we need to do? Do we need to go to the customer? All of that needs to be in place. Then we need to know how we do OS updates, Kubernetes updates, patch levels, OS upgrades. We can do that with Suma. We can do that with Elemental. Depends on the customer, depends on how we want to do it, but we need to define it at this point. Here, we have to have it written down. Then we need to figure out upgrades for Kubernetes. We should have that regularly, right? We all know, only go from 125 or 131 to 132. Don't skip versions. All of those wonderful things need to be handed over to operations. Good. And then in the end, we'll have to teach our application teams. Hopefully they are on board already, but maybe we'll need to teach. And finally, disaster recovery. The backups we don't need, they should know how to use them, even if they don't need them. And that sums it up. Questions and answers. Hopefully questions with answers. Let's see. If you are interested in more technical things, feel free to approach us. We'll be at the services booth. We have all of that, what we've shown you in theory, also on our notebooks, so we can show you if you're interested.
All right, I guess if no questions are there, thank you very much for attending. Please reply to the survey if you get one. Only positive. No, just kidding. We are happy to get all the feedback, positive as negative, to improve. And with that, thanks a lot for your time, and looking forward to seeing you implementing that stuff and providing us further feedback. Thank you.